better than a telephone, I think.
Yeah.
And you should be looking at my desktop.
Mm-hmm.
And hold on, let me open a drawing tablet. And whatever I write on this, you should be able to see. You can see that okay?
Yeah.
Okay. Now, in terms of working with your online stuff, we can do this a couple of ways. Probably the easiest thing for us to do is for you to give me the online site, let me log into it, and then all of the problems we have to do are going to be on my screen, which we will both be looking at.
Okay.
So, you see under the Go to Meeting, there's a chat window near the bottom, and then under that
Yeah.
it says type message here.
Mm-hmm.
If you can copy and paste the address to the problems you want to cover in that, then I can click on it and open it up immediately.
Okay.
I might need a password and username, but that's probably the easiest way to do this. Okay, let me go there. Okay, do I want to click on derivatives of logarithms?
No, I think you scroll down so you can see the homework.
I see a bunch of stuff down here. Which one do you want me to click on? Do you see the same stuff that I'm looking at?
Yeah.
Okay.
Yeah. The homework is actually, if you scroll down on that page, the questions are below all those notes and things.
Hold on, let me do that. Let me get this. Now, incidentally, that gray Go to Meeting screen, if you want to reduce that, hit the orange square, the white arrow in the orange square, and then it minimizes it. And that's a toggle switch. So you can always open it and close it by hitting that orange square.
Okay.
So let me scroll down here. Okay.
So I did 1 through 5. So I was hoping just to go over 6 through 9, and then try to get through one more assignment.
Okay. So let me just take a quick look at this. Okay, the main thing is the derivative of natural log of x is 1 over x.
Okay.
And each of these 1 through 5, we're going to apply the chain rule. In other words, we're going to do, for number 1, it would be 1 over the square root of x plus 1 times the derivative of the inside, which is 1/2 times the square root of x plus 1 to the minus 1/2. Okay, so let's start with number 6. Let me reduce this so I can get my other drawing thing on here. All right, number 6 says y equals natural log of x divided by e to the x. Find dy dx and the second derivative of that. Okay, so let's solve for y prime.
Okay.
Same thing as dy dx. What are we going to use? Which rule?
The natural logarithm rule?
Well, that, but also the quotient rule.
Okay.
In other words, we have something being divided by something else. So what's the quotient rule? I have a really easy way of remembering it. How do you remember it?
I just remember how it's like the product rule, except it's minus instead of plus.
Well, here, let me give you my way. You might like it. Starts with the bottom and ends with the bottom squared. That's all you have to remember. Okay? Now, if it starts with the bottom, that's the first thing you write.
Okay.
The second thing must be the derivative of the top, which is 1 over x. Okay? We know that subtraction is taking place because the order matters. In other words, when you're doing the product rule, it doesn't matter which order they're in because addition is happening. But when subtraction is happening, the order matters a lot. So that's why you have to start with the bottom, and then this term over here is going to be the reverse of this. It's going to be the derivative of the bottom times the top. Well, what's the derivative of e to the x?
E to the x.
Times the top, all divided by the bottom squared. What's the bottom squared? What's e to the x times e to the x?
E to the x squared?
Well, e to the 2x.
Oh.
Remember, when you're multiplying e to the x times e to the x, you add the exponents. Well, x plus x is 2x. All right, so this is the first derivative. Now, getting the second derivative, well, first of all, let's talk about the first derivative, because this might not be the format you want to put it in. I notice right off the get-go that I can factor out an e to the x from the top. And that means I can divide the bottom by e to the x also. So if I factor out an e to the x from the top, what am I left with? I'm left with 1 over x minus natural log of x all over e to the 2x. And now we can do something with the e to the x and the e to the 2x. We can, what? What's e to the x divided by e to the 2x?
It would just be 1.
Okay.
And the bottom would be e to the x.
You got it. So that 1 basically cancels out with that. And now on the top, I've got this. Okay? So that's y prime. And we can simplify that a little bit by finding a common denominator on the top, and we probably should do that, because otherwise it's going to be difficult to take the second derivative unless we simplify this a little bit. Okay, so what's the top simplify to? We got 1 over x minus, how do I find a common denominator? What is the common denominator going to be?
Would be x.
Right. So what does this numerator have to be such that I don't change that?
The natural log of x squared.
Not quite. It's x natural log of x. Okay? In other words, if I had x natural log of x divided by x, the x's cancel and I have the same thing I started with. That's always the key, is that you have the same thing you start with. And you should always do that check as you're doing these. Okay, and this whole thing is divided by e to the x. So now what do I have? I have in the numerator, I have 1 minus x natural log of x all over e to the x. Well, that means that e to the x I can put here. You see why?
No.
Okay, well, let's put a 1 under that, e to the x. How do we divide fractions by fractions? We take the reciprocal and multiply.
Oh, okay.
Okay, so this becomes x e to the x. So that is our y prime simplified as much as we can simplify it.
Okay.
Okay, now y double prime. The second derivative of that is what? What's the rule?
The quotient rule.
What is it?
Start with the bottom.
And end with the bottom squared. That's all you need to ever remember, because you can't get it wrong once you do that. Okay? So, starting with the bottom, I know subtraction has to take place. And I know excuse me, it's the bottom times the derivative of the top. What's the derivative of the top? Boy, this gets really complicated for the second derivative. What's the derivative of the top? Because now we have to apply the product rule. So let's start with the first term, minus x, times the derivative of natural log of x. What is that?
Okay. The 1 over x.
Okay. Plus the reverse, which is the derivative of minus x, which is minus 1, times the other term. So, here we have the bottom times the derivative of the top. Let's rewrite that, just so I have enough room.
Okay.
Well, that thing's minus 1 minus natural log of x. And then we need to subtract the reverse. Right?
Mm-hmm.
So the reverse would be the top times the derivative of the bottom. Well, there's the top. What's the derivative of the bottom?
X e to the x.
Well, no, we got to apply the product rule.
Oh.
So it's the derivative of x times e to the x plus the derivative of e to the x times x. So that's the top for our second derivative.
Okay.
What's the bottom?
X e to the
it's this squared. What do you get when you square x e to the x squared? What is that equal to?
x e to the 2x.
Well, close. X squared, you have to square both terms. E to the 2x.
Okay.
Okay. So x squared e to the 2x. So just applying the quotient rule twice gets us to this point.
Okay.
Now, simplifying this. Well, I guess the first best thing we can do is distribute this stuff.
Okay.
Well, what is that? Minus x e to the x minus x e to the x natural log of x. That's this part over here. Oh my goodness. Why do they give you such complicated problems? This is amazing. All right, so I have to multiply these two things together. Let's see what that is. What's that equal to? FOIL it.
It would be e to the x minus x e to the x.
Okay, the first term you get from that. Let's keep a methodology here by taking the first term and multiplying it by the second term. So plus x, oh, that's what you said. And the third term?
Could be,
in other words, now we're going to multiply that by that.
Negative x natural log of x e to the x.
Yeah, let's write it like this. Whenever you have natural log, it's best to put it at the end. Otherwise, it can be confusing.
Okay.
And then finally, this times this.
The x e to the x natural log of x.
X squared, because x times x is x squared. And I have an e to the x, and I have a natural log of x. Okay. So that's what that multiplied together is. And we need to subtract that entire thing. Oh man, the algebra here is ridiculously tough. I'm not sure why they're focusing so much on complicated. Hold on. Minus e to the x natural log of x minus x squared e to the x times natural log of x. All right. So that is our second derivative unsimplified. What's the next step? Remove the brackets. Before we can figure out how to simplify this, we got to get rid of these brackets. Okay? So y double prime equals minus x e to the x minus x e to the x natural log of x. The rest of it?
Would just be the same.
Well, remove the brackets. This becomes a plus, and this becomes a plus.
Oh, okay.
When you remove the brackets, the one mistake that it's always possible to make is with the sign. There's a lot of sign problems.
Okay.
So, is there a greatest common factor? If that indeed is our answer, what can we remove from that?
Could remove an e to the x.
Looks to me like there's an e to the x in every single term. So, let's factor out an e to the x, leaving minus x natural log of x minus 1 minus x plus x natural log of x plus x squared natural log of x. Now, I don't see anything else we can factor out in terms of a greatest common factor, so our next step is to simplify what's inside the parentheses. How many x's do we have?
-2.
Okay, minus 2x. How many of these do we have?
0.
Right? So we've taken care of that and that. So we still have this plus x squared natural log of x, and we still have the minus 1. That should be the answer.
Okay.
Not sure what their purpose is in giving you this problem, other than to impress upon you the detail of or the importance of accuracy. Because clearly, if I made any arithmetic error at any point along, I mean, how many steps was this? This was like 10 steps. If I made one mistake, I am not going to have the answer right. So I'm going to have to go with this as the answer, and if it's not right, I would have to start from scratch, go through it all again, and try to figure out where I made my mistake.
Okay.
Okay. All right, let's go to the next one. Now, just so you know, you don't have to be writing any of this down. You're going to get a copy of the recorded file. So everything that I write, you're going to see again if you need to.
Okay, great.
Okay, so it's actually a little better than in person because you don't have to. It's almost better. It depends on what kind of learner you are. If you're somebody that learns better when you're writing it down, then go ahead and follow along with me and write it down. But some people learn better by just watching and listening. And if you're that kind of person, then you're probably better off not writing it down and waiting until you get the copy of the file. It does take my computer 3 or 4 hours to process these files. So I don't post it until 3 or 4 hours later, so it kind of depends on when you need it. You know, if you had a test in 2 hours, that wouldn't do you very good. But if you have a test tomorrow, then you'd have time to review this thing. All right? All right. So, what was that? That was number 6. Take a look at number 7. Find an equation to the tangent line. Okay. Well, all equations of tangent lines start out with slope, right?
Mm-hmm.
At the point e comma 0. It's the same thing as the point 2.71 comma 0. Not quite.
Okay.
E is more accurate than 2.71 is. But my point is it's just a number. E is just a number. Okay? So, to figure out the equation of the tangent line, what do we have to do?
Take the derivative.
Okay. This is an interesting thing they put there. Okay. In other words, what they're telling us with this note is that I can write this a little better for taking the product rule. Since the natural log of the natural log of x is equal to this, I can write it like this. Now it's going to be easier to take y prime. What's the product rule?
It would be...
Oh, hold on. Excuse me. Did I do that right? Yeah, I did. Okay. It's not actually the product rule. It's the chain rule we're going to need.
Okay.
What's the derivative of the outside?
1 over the natural log of x.
What's the derivative of the inside?
1 over x.
So there's the derivative.
Okay.
You notice why we're not using the product rule. There's nothing being multiplied here.
Uh-huh.
This means the natural log of the natural log of x. So it's just a natural log function. But whenever you have a natural log function, like if I had the natural log of 2x and I wanted to take the derivative of it, it would be 1 over 2x times the derivative of the inside.
Okay.
Okay? So this looks very complicated, but it's really not.
Okay.
It's this. Okay, so now we need to evaluate that at this point, e comma 0. So y prime of e comma 0 is, well, we don't have a y, so we need to substitute x for e. What's the natural log of e?
1.
Okay. So y prime at e is equal to 1 over e. So that is the slope.
Okay.
At that point.
Okay.
So far, we haven't used the 0 at all. But we're going to need to come up with the equation of the line, because the equation of the line in point-slope format is this. So plug in. What's our y and what's our y sub 1?
0.
So we have y equals our slope.
1 over e.
And x minus
E.
So there is the equation of the tangent line at that point.
Okay.
Now, I guess, I'm not sure what format they want it in. You could do a lot of things here. You could distribute it so you get this. That might be a prettier answer. But this might be just as good.
Okay.
Okay. I tend to like leaving answers in factored form. merely because if something's already factored, whatever the next step is usually easier. So rather than taking two things that are already factored and multiplying back together again, I prefer, if it was me, I would prefer that as an answer.
Okay.
Okay? But it's hard to say. I never know what the class or the teacher wants. Graph both the function and the tangent line. What kind of calculator do you have, Callie?
I have a graphing calculator.
What kind? The TI-84, 89, or an Inspire?
I think it's the TI-84.
Okay. So, in order to graph y equal natural log of x, you can graph that on your calculator. In fact, let me do it. I have a virtual calculator here. Let me find it. Is this the kind you have?
Yeah.
Okay. Didn't like that, so I typed it in. Hold on. Just a second. Let's see. Natural log. Why is that first parenthesis there? Okay. So, the natural log. Still put it there. Ah, I get it. Hold on. Takes me a while to figure out how to use this thing. Alright, I gotta use this natural log too. So it's the natural log of x. Oh boy, and I'm in parametric mode. Let me put it in function mode. Let's try that again. Natural log. Oh no, I did the same mistake. Sorry. I keep making the same mistake here. Sorry about that. That's, clear. Let's see. Let's clear it. Okay, I got to hit the natural log of the natural log of x, and I need two parentheses. Now let's graph that function. I'm not sure how they're going to want you to do this for your test. But it clearly is something like this. And they said graph both the function and the tangent line. Well, the tangent line is at e comma 1. E comma 0, excuse me, which is almost certainly that point right there.
Okay.
Let's see. The natural log of e would be 1. The natural log of 1 is 0. So it is this point right here.
Okay.
That is e comma 0. And we need a tangent line there, and our slope of the tangent line is 1 over e? Well, 1 over e is 1 over 2.7. It's a slope that's going to look something like, it's going to be less than a half. In other words, that's a slope of 1. That's a slope of a half. That's a slope of 2. Okay, so we need a slope that's a little bit less than a half. There's the graph of both the function. That's y equal natural log of natural log x. And this is the equation y equals 1 over e times x minus e. Okay?
Okay.
So this is the page. If I was having to show them a graph on a PDF file, this is what I would show them with arrows pointing to the equation of each line.
Okay.
All right. Number 8, use logarithmic differentiation to find the derivative of x to the 3x. So, in other words, if that's y, what's y prime?
Okay.
How can we do this? Can we use the power rule?
Yeah.
No. Why? Because the exponent has a variable in it.
Oh, okay.
Okay? When the exponent has the variable, you can't use the power rule. But how do we get that variable onto the equation line? What if we take the natural log of both sides?
Okay.
So now we have the natural log of y equals the natural log of x to the 3x. Now we can apply the rules of logs and bring this 3x down here so that we now have natural log of y equals 3x, natural log of x. You with me?
Mm-hmm.
Now differentiate both sides. In other words, this is a frequent problem. Whenever you have an exponent that's the variable, your first step is always going to be taking the natural log of both sides.
Okay.
Because that allows you to bring that exponent down onto the algebra line.
Okay.
Now we have an algebraic equation. And I'm going to differentiate both sides. What's the derivative of the left side with respect to x? In other words, here's what I'm doing. I'm going to take the derivative of that with respect to x, and I'm going to take the derivative of this with respect to x. So what's the left side?
Be 1 over y times dy over dx.
And the derivative of the right side.
It'd be 3, well, you'd have to use product rule.
So this was the derivative of this times that, plus the reverse. What's the reverse?
1 over x times 3x.
Like that?
Mm-hmm.
So now dy dx ends ends up being this whole quantity multiplied by y. You with me?
Mm-hmm.
Now, what is y?
X to the 3x.
Whoops. In other words, if we want our final answer to be a function of x entirely, that's it.
Okay.
This is an important problem because there's a lot of times where, what's the limit of this as x goes to 0? Well, the only way to answer that question is to take the natural log of both sides, differentiate both sides to come up with the answer. So whenever you have the variable in the exponent, know that your first step is to take the natural log of both sides.
Okay.
All right, use logarithmic differentiation to find this. All right. There are some problems, like this one, that would be extremely difficult to do if we had to apply the product rule and the quotient rule. Right? And you can see why it would be tough. My textbook has something that's about 4 times more complicated than this, but illustrates the same problem. And the thing is that differentiation is tough for things that are being multiplied and divided, right? You would agree? I mean, the product rule and the quotient rule, this thing's going to get complicated fast. But what if I take the natural log of everything? This is another problem where it can be easier taking the natural log of both sides. Why? Because now it allows me to take each of these things separately. In other words, I'm going to take the natural log of that plus the natural log of this minus the natural log of this.
Okay.
So far, it's not clear why this is easier, but bear with me. This I can write a little bit better, this bottom part here. In other words, that's the same as 5x to the 1/2. And now I can take that exponent and stick it in front. So I get minus 1/2 natural log of 5x. Okay? You see that's... Okay. Now that I have everything in natural log, I can start differentiating. And it's going to be really easy to differentiate this. Much easier to differentiate this than it would have been to differentiate the top row here. What's the derivative of the left side?
1 over y.
dy dx. See why you have to follow it with a dy dx? Because we're differentiating with respect to x. Since y is not x, I have to apply the chain rule.
Okay.
What's the derivative of that?
1 over negative y minus 4.
1 over negative x
negative
minus
x,
4.
sorry.
What's the derivative of the inside?
Negative 1.
Which changes those to a plus. How about the second term? What is that?
1 over 3x plus 1
times
3.
So it's 3 over 3x plus 1. And finally, the derivative of the last part.
The
Step by step.
And then 1 over 5x.
And the derivative of the inside
is 5.
Okay. So now we're down to this step. So dy dx is equal to y times this whole thing. Well, y is this complicated thing here. And I can write it out like that, or I can write it out like this. Now, you might say that, well, that's pretty complicated still. And it's true, but it was easier to get the derivative when I wrote it out like this. Actually, the 5's cancel here. And I end up with 1 over 2x. So that's either this is your answer, or you can go back and substitute what y is equal to. Y is equal to this big complicated thing here.
Okay.
Okay. Mainly what this is a demonstration of sometimes it's easier to take the natural log of both sides before you try to figure out the derivative. And that's why it says use logarithmic differentiation. Same thing here. It didn't say use differentiation, because I could have differentiated this a number of different ways. I could have used the product rule and the quotient rule and driven myself crazy with the complexity of it. But if I take the log of both sides first, the key is that once I've taken the log of both sides, it changes it into the derivative of a bunch of things that are being added or subtracted. And that's always easier. Those things are being added or subtracted, not multiplied or divided. So it becomes really easy to take these derivatives of stuff that's being added and subtracted. All right. What's next?
On that internet browser, if you click on that bottom thing that says 13, Introduction to Differential Equations and Exponential Growth and Decay, then that takes you to the next assignment.
And what do we want to click on down here?
I think maybe just start the homework too. I watched almost all of the video. I think I just missed about the last 5 or 10 minutes of it.
Okay, so we want to start with number 1?
Yeah.
Okay. Let me get an idea of where we're headed so that I can prepare a little bit better when we have the next session. What's coming next? Is this the order of the things that are coming?
This was kind of the order of this lesson.
Okay. So this doesn't really tell me what we're going to do at our next session.
No.
Oh, that's fine. Some of these things I don't run into very often. Newton's law of cooling, that would be something I would want to review. The general solution of harmonic oscillator equation I would want to review. But So far, I think I can handle everything you showed me. All right. If I start with a differential equation, how do you solve a differential equation? Incidentally, all differential equations are always going to have these in pairs. You're never going to find something like this. It's always there's going to be a dy and a d something else.
Okay.
The best way to solve these are to separate the variables and then integrate both sides. Well, if I separate the variables, I get this. You with me on that step?
Mm-hmm.
Now integrate both sides, which you can always do. Integration is just one more thing that you can do to both sides of an equation whenever you want it, just like differentiation or taking the natural log of both sides. What's the integral of dy?
We haven't done integrals yet.
Yeah, I was a little surprised at seeing this because that's what's needed to do these. The integral is the inverse of the derivative. Let's just talk about that for a second. Maybe that's what we should talk about here.
Okay.
If I said x squared, if y equals x squared, then y prime equals 2x. And if this was the only thing you had, in other words, if I gave you what y prime was and I said, tell me what y is,
Mm-hmm.
you're going to use the reverse of the product rule. We're going to add 1 to the exponent, and we're going to divide by the new exponent. So it becomes 2x squared divided by 2, which is x squared.
Okay.
Okay? So integration is the reverse of differentiation. Now, before I go beyond that, I should say that that makes it sound a lot easier than it is. And I mean that with the utmost reality. Because differentiation, I don't care how complicated of a function you give me, I can differentiate it with either the product rule, the power rule, the quotient rule, and the chain rule. Between those 4 rules, I can differentiate anything.
Mm-hmm.
Integration is not like that. There are a lot of things that integration is extremely difficult to do. And in fact, in other words, let's say I ask you to integrate this. Well, there's no product rule for this.
Mm-hmm.
Excuse me, I meant e to the x squared. So integration is, well, let me put it this way. If differentiation is a 4 on a 10-point scale of degree of difficulty, integration is a 9.
Okay.
That much different. Okay?
Okay.
You have to learn. It's really easy if you have one term. If I'm integrating that, it's the reverse of the power rule. I add 1 to the exponent and divide by the new exponent. So as long as it's a simple function, integration is very easy. And if you take the derivative of that, you have to get that. That's what I mean by integration is the inverse of differentiation. In other words, when you integrate something, whatever you get, if you take the derivative of it, you get back to where you started from. So it's the true inverse. inverse means a function that undoes what the original function did. If I want the inverse of x squared, it's square root of x. Why? Because the square root of x squared equals x. In other words, I get back to whatever I started with by an inverse function. Hold on. So, since you have not had integration yet, why are they giving you these? Is it just you haven't watched the video on integration, or?
No, I don't think so.
There's three main areas of calculus. There's limits, there's differential calculus, and there's integral calculus. And that's kind of Calc 1, Calc 2, and Calc 3. And then there's infinite series, which is part of Calc 3. Actually, Calc 2 would probably cover a little bit of differential calculus and a little bit of integral calculus. But integral calculus is a whole new ballgame.
Okay. Yeah, no, we haven't had any integration videos.
Well,
no.
Let me show you how to do this one, and then you can tell me where we want to stop.
Okay.
You might want to watch some integration videos before we attempt to do these problems.
Okay.
This is called a differential equation. Why? Because it has differentials. Anything that has a differential in it is a differential equation.
Okay.
This is a first order simple differential equation. Why? Because I can separate the variables and then I can integrate. In other words, if I multiply both sides by dx, I get this. Now if I integrate both sides, well, the integral of dy is 1 over y because the derivative of 1 over y, hold on. The integral of dy is y because the derivative of y is 1. Okay? In other words, when you take the integral of something, you always need to be able to take the derivative of what you get and get back to the original. Well, there's a 1 there.
Okay.
Okay? It's implied, it's not written, but there's a 1. So when I integrate 1, I get y. Just like if I differentiate y, I get 1. Okay? Now, on the other side of the equation, the integral of x plus 1 dx is the same as the integral of x dx plus the integral of 1 dx. In other words, just like differentiation, the integral of the sum is the same as the sum of the integral. Okay, you with me? Okay, well, what's the integral of x? Add 1 and divide by the new exponent.
It'd be x squared divided by 2.
And how about what's the integral of 1 dx?
X.
Okay. And here's the thing about integration. If I take the derivative of this, I get x plus 1, right? But if I had some constant added to that, and I took the derivative of it, what would I get?
0.
No, I would still get x plus 1.
Oh, okay.
In other words, having this constant, when you integrate something, you can add any constant to it that you want. Because when I take y prime now, I get x plus 1. It doesn't matter what this constant is. So when you take the integral of a function, you actually have an infinite number of solutions. And they're saying that, is this one solution? Well, yes, it is, because c could be 3. In other words, I can let c be 3, take the derivative of that, you get x plus 1.
Okay.
So that's all integration is it's figuring out antiderivatives. In other words, that's a real term in calculus, is figuring out the antiderivative.
Okay.
What's the antiderivative of this?
The 3x to the 5th divided by 5.
That's it. Plus c.
Oh, okay.
Always plus c, because notice that if I take the derivative of that, I get that. So I can add any c that I want, and it would still be the integral of 3x to the 4th.
Okay.
Okay? And I would say that's probably a good place for us to stop.
Okay.
I think you probably need to watch the video on integration. When you go to integration, that's a big step from differentiation. Differentiation, like I said, is about a 4 on a 10-point scale, and integration is an 8. It isn't if you're just talking about the power rule. But if I have something like this, I can't use the power rule on that. I have to go through a technique called integration by parts. You have integration by parts. You have integration by partial fractions. You have integration by trig substitution. You have integration by approximating infinite series, and believe it or not, there are some functions that do not have an antiderivative, like that. There is no function in the universe whose derivative is equal to this.
Okay.
Okay? And in order to integrate something like that, we have to find an infinite series that approximates it, and then integrate the infinite series term by term. So integration can really be a bear, merely because you don't have 4 simple rules to handle integration, and each technique is extremely difficult. It's not like the 4 rules of differentiation. So integration is a whole nother animal. So my suggestion would be go ahead and watch the video on integration, and then let us tackle these. Now something like the second problem here, I'm going to have to integrate it twice. They're telling me the second derivative is minus y, so I need to integrate it once to get dy dt, and then I need to integrate it again to get y. So, yeah, you're getting into some very complicated stuff here.
Okay.
Let me think for a second. I would like to be able to review this before we have our next session. Can I somehow? Yeah, I have the, I didn't need a password to get into this, did I?
No.
Okay. So it's okay if I just leave this open? All right. That'll give me a chance to review it. Now, give me a email address. You may have it. I do have your email address. I don't need it. And what I will do is send you a link to get access to the recording of this session.
Okay.
It won't be for a few hours, maybe 4 or 5 hours.
Okay.
But you'll be able to go back and replay this session on a YouTube file if you need to, and given the way you have to turn in your homework, I could imagine that would be very helpful.
Yeah.
You can just go back to the beginning and go through each problem.
Okay.
Okay? So I will send that to the email address that you sent me your last email with.
Okay.
And if you like, it's almost easier for me to schedule appointments than it is for you to go texting me about it.
Okay.
Do you have an idea of when you might want your next appointment? And if you do, I'll go ahead and put it down right now.
I'm actually not sure yet because we're leaving on a trip for tomorrow.
Okay.
So, yeah, I don't actually have a really good idea about what my schedule is going to be like for the next couple days.
Okay. Well, when you get it, you can email me or text me, and
okay.
we can set up another.
Okay, great.
Okay. All right, Callie. Have a good vacation.
Thanks.
Bye-bye.
Bye.